So right now I want to go through a couple of graphs. I actually have 4 that I'm going to try to get through to just give us all a refresher on some easily confused functions. And my sound is going out and in, so hopefully it will stay with us. So up above you will see sketched a graph of y equals cosine x. Some things I want you to notice. The y values are popping back and forth between -1 and 1, just like we expect. And then my x values are labeled with angle measurements. And you can see it in darker print in radians and then down below the degrees, just in case you were curious. So if I want to do secant, the first thing I need to remember is the relationship between cosine and secant. And so cosine, or let's go this way, secant x is the same thing as 1 over cosine x. It's the reciprocal function. So I'm going to plot my secant by plotting some points. And since cosine x can be 0, if I divide by 0, that's what happens at my asymptotes. So I will have zeros and asymptotes. So this is pretty much how it's laid out in almost every trig book. First you graph cosine, and then they will show a picture just like I have drawn, where they have dotted lines coming down from your zeros and your maxes there. So if I start with this point on the cosine x graph, so that y value is 1. The y value on secant is 1 over 1, and that's still 1. As I come down this way, and I'm going to give this slightly calc feel because this is for my calc class. Notice that my y values, my cosine values, are positive but getting smaller. My secant values, they're positive because it's just reciprocal. That doesn't change the sign of something. But if the cosine values are getting smaller, the secant values are getting bigger. The limit, ready? Here's the limit language. As x approaches pi halves, the limit of secant x goes to positive infinity. What about over here on this left side between 0 and negative pi halves? Notice my cosine values, positive, and getting smaller. So my secant values, positive 1 divided by positive numbers from the cosine, positive and small on the bottom means positive and really big for secant. So at negative pi halves, I also have a vertical asymptote in the positive direction. So let's take a look at this next little chunk between positive pi halves and positive 3 pi halves. So I'll start at pi. So when x is pi, cosine is -1. And the reciprocal of -1 is still -1. So at pi, my secant is down here at -1. Over here, close to pi halves, my cosine values, remember y is graphing cosine x. So if I read off the y values here, just past x is pi halves, those y values are super small and negative. So my secant values, I have positive 1 over super small and negative, means that I have some negative infinity values in here. Heading up, going toward -1. And then same idea over here at 3 pi halves. And this pattern, cosine has a period of 2 pi, and so does secant. And it just keeps repeating. So calculus students, you can imagine, or at least you should, me asking the question, hey, what's the limit of secant x as x approaches pi halves from the right? So you have to get on your x-axis near pi halves to the right. So this is my x-axis, so I'm going to hop on right around pi halves, coming from the right. Oh, get on your graph though. As I'm walking in, what's happening to my y values? Right? They're all headed toward negative infinity. Versus if I asked, hey, what's the limit of secant x as x approaches pi halves from the left? Okay, well, this time when I get on my graph on pi halves, I'm on the other side of it. Right? I'm over on the left side and I'm walking, right? Walking along from the left, and this time my secant values approach positive infinity. Okay? So secant x, right, has a whole bunch of asymptotes, and it's the reciprocal function of cosine. So the way I always graph it so that I know if it's the one that's even or odd is I graph cosine. I actually bring down my zeros of cosine and know that's where my asymptotes are. Okay. Now the one that can be confusing then is, well, what about inverse cosine? So up here you can see I have just redrawn y equals cosine x, but I've just taken one period of it. I don't have that whole other business because I'm going to ask you to remember way back to inverse functions. In order for a function, cosine is one, to have an inverse, your function needs to be 1-to-1. And 1-to-1 in math, visually, means it will pass a horizontal line test. So not only each x gets one y, but each y only has one x. So in fact, the amount of cosine I have drawn is too much. I can only take a small chunk of it. I need to stop here where x is pi so that my cosine graph will pass the horizontal line test. So before I can start talking about the inverse cosine, I need to restrict the domain of cosine to the interval 0 to pi so that it stays 1-to-1. Now, this next part that I have to do, I have to make myself some notes so that I don't get confused. Inverse cosine, y equals inverse cosine of x. The inputs are angles. Right? I take the inverse cosine of ratios. See, here I am getting confused. Inverse cosine of ratios, the output is the angle. Okay. So I input the ratios and I output angles. I also know when I'm looking for inverse functions, the x's and y's trade places. So up here on my original, my cosine x graph, I'm going to label 3 of the points that I know. I see the point 0, 1. I see the point pi half 0. And I see the point pi negative 1. When I come down to graph my inverse cosine, I'm just going to flip those 3 points and find them on my graph. So I need to find the point 1, 0 and the point 0 pi halves and the point negative 1 pi. Okay. So let's find those on that bottom graph. So I have the point 1, 0. Okay, can I go all the way over there? I guess I will. I won't be drawn to scale. There's 1, 0. I have the point 0 pi halves. 0 pi halves, so wherever pi halves might live. And I have the point negative 1. Uh-oh, where's that? Over here, right? There's negative 1. and pi. So I have these 3 points, and I'm just going to draw them with some sort of swoopy cosine. Perhaps when we get to Calc 2, we'll talk about some concavity and if I have it drawn right. But that's going to be good enough for now. Do I need, and why not, more graph? So domain range of cosine x. I had to restrict it to be from 0 to pi, so it stayed 1 to 1 for the domain. That means my range of inverse cosine has to be the same, 0 to pi. True? Yep. This was my x-axis, my y-axis. My y's go from 0 to pi. Great. What was the range on cosine? Even the abbreviated cosine, it still went from -1 to +1. How about the domain down here on inverse cosine? Does that go from -1 to +1? Absolutely. Okay, so inverse cosine is just this itty-bitty little chunk. I have to restrict the domain. If you think graphically, up here you can imagine the line y equals x going through and doing your symmetry across the line y equals x. I have a hard time seeing it on this one, but it should be symmetric. So inverse cosine versus the secant. Now the other one, the reason I have those dotted lines in that shouldn't be here for that one, is because I wanted to talk about tangent. So if I look at tangent versus cotangent. So cotangent is 1 over tangent. So the same idea. When tangent is 0, I'll have an asymptote. Okay. So tangent 0 when x is 0, so cotangent will have an asymptote. I'll have another asymptote here at pi, and another asymptote over here at 2 pi, at -pi. Okay. And now how about my intercepts? And it would be easier to have the discussion writing cotangent as cosine over sine, but we're going to go ahead and have it the other way. So over here between 0 and pi halves, my tangent values are positive, so my cotangents will be, let's find pi halves on my graph. So I'm going to be positive. My tangent values get super big and positive as I get close to pi halves. So down here on cotangent, I have 1 over super big and positive. 1 over super big and positive looks a whole lot like 0. So this asymptote here is a 0. But between 0, stay with me, between 0 and pi halves, my tangents are positive and my cotangents are positive. That dotted red line was an asymptote. So I need to be an asymptote to the dotted line, stay positive, come down and hit that x-intercept. Now between pi halves and pi, my tangent values are negative, and my tangent values start negative and big, which means my cotangent values are negative and small. Then if my tangent values stay negative but get smaller and smaller, cotangent 1 over small and negative. There's my other asymptote. So that same pattern, when cotangent's, or when tangent's positive, so is cotangent. When tangent's negative, so is cotangent. Okay. So my asymptotes are at the 0. So there's my pi. Does that line up? Maybe that's so that lines up. So positive tangent, positive in an asymptote, heading towards a 0 at the asymptote of tangent. Okay. So cotangent is kind of like tangent but flipped and shifted, versus inverse tangent. So here's that same y equals tangent x. In order to find an inverse function, I need my original function to be 1 to 1. So we're just going to choose 1 period. We'll restrict the domain of tangent to be from negative pi halves to pi halves. The range, right, notice it keeps on going. It stops, the graph stopped it at 10 and negative 10, but it keeps going forever. Those are going to switch down here for inverse tangent. So the domain of inverse tangent, negative infinity to positive infinity. The range of inverse tangent is just between negative pi halves and pi halves. Okay. So I'm going to dot in some limiting values there for my range. It's bouncing back and, okay, it's not bouncing. It's constrained by negative pi halves and positive pi halves. So let's see what kind of values I have. So on my original function, I have 0, 0. Well, if I flip those around, I still say 0, 0 down here. So that's on my inverse function as well. Now, let's think about this. I can't do a reciprocal. It means something different. I have angles going in. So if my angle is positive, so if I'm going toward, how do I want to say that? Let's look at the unit circle. So in my unit circle, over here in quadrant 1, between 0 and pi halves for my angles, right? Those ratios are all, the tangent ratios are all positive. So for inverse tangent, my inputs are the ratios. So when I have positive ratios, okay, my tangent, or my angles, are all positive. So over here, the tangent ratios are positive, and the angles are positive, 0 to pi halves. Between my angles, if my angle goes between 0 and negative pi halves, down here, right, coming down on my unit circle, okay, so now I have negative angles, right below the x-axis on my inverse tangent graph. And the ratios, in this case the inputs, right, are also negative because, right, those tangent ratios down here are also negative. So I have some asymptotes. I have some horizontal asymptotes at pi halves and negative pi halves. I have an infinite domain. It's 1 to 1, and it's a function.